Hello students, today we are going to discuss the last topic of chapter 7 coordinate geometry, area of triangle. Now there are basically three methods from which we can calculate area of triangle. Let us discuss them. Area of a triangle can be found using three different methods. The three different methods are discussed. Method 1, when the base and altitude of a triangle are given. So we can calculate the area of triangle as half into base into height, where B and H are base and altitudes of triangle respectively. Suppose we have triangle A, B, C, and we know the height as H and the base as B. So you can simply apply this formula to calculate the area of triangle. Now method 2. When the length of three sides of the triangle are given, the area of triangle can be found out by using Heron's formula. As you have already studied the Heron's formula, which is what? S minus A, S minus B into S minus C, where A, B and C are the side length of the triangle and S is the semi-perimeter. Again we have to consider a triangle whose length of sides are given. Suppose this is A, this is B and this is C. So you can easily calculate the formula by using Heron's formula. First you have to find out S, which is semi-perimeter, means you have to add the length of sides divided by 2, you will get S. Simply substitute the values, so you will get the area of triangle. Now method 3, if the vertices of a triangle are given. Now we know the vertices. Means what? If I have a triangle, as you can see over here, this is triangle PQR, PQR, and you know the vertices. P as x1, y1, Q as x2, y2 and R as x3, y3. So, if the vertices of a triangle are given, first we have to find the length of three sides of triangle. Now how you can find the length of three sides of triangle? By using distance formula. So let us assume a triangle PQR whose coordinates P, Q and R are given as x1, y1, x2, y2 and x3, y3 respectively. Now we have to see the figure. From the figure, what can you see? The area of triangle PQR. We have to construct lines such as QA, this is QA, PB and RC, this is RC, from points Q, P and R respectively. Now, three different trapeziums are formed such as PQAB. This is the first trapezium. Second one, PBCR. This is the second trapezium. And QACR. This is the third trapezium. Now we need to calculate the area of all the three trapeziums. Therefore, we can calculate the area of triangle PQR as area of trapezium PQAB. This is the first trapezium plus area of trapezium PBCR. This is the second trapezium. We have to subtract this trapezium so that we can calculate the area of triangle PQR. So now we need to calculate the areas of all the three trapeziums. Finding area of trapezium PQAB. What we have to do? We have to apply the formula for finding the area of trapezium, which is what? Half into sum of parallel sides into distance between them. As you can see here, PQAB. We have considered this trapezium first. So, here are the parallel sides are QA. Where is QA? Say this is QA plus PB. Both are parallel. And the distance between them is what? AB. So, substituting the values in the formula, what will you get? Half into sum of parallel sides means QA plus PB into distance between them means plus into AB. So, now you have to substitute the values of QA, PB and AB. What is QA? This is Y2. This is Y2. So, QA is Y2, PB is Y1. As you can see, PB is Y1. And AB is what? AB. OB minus OA. So, OB is X1, OA is X2. So, AB is X1 minus X2. So, area of trapezium PQAB will be half into, substitute the values, Y1 plus Y2 into X1 minus X2. Now, we will find area of trapezium PBCR. This is PBCR. So, again we have to apply the formula half into sum of parallel sides into distance between them. Here the parallel sides are PB and CR or RC and the distance between them is BC. So, the area of trapezium PBCR will be half into PB plus CR into BC. Now, substitute the values of PB, CR and BC. What will you get? You have PB as Y1, CR as, this is CR or you can say RC, this is Y3. And what about BC? BC is OC minus OB, which will give you X3 minus X1. Simply substitute these values here. You will get area of trapezium PBCR as half into Y1 plus Y3 into X3 minus X1. Now we have to calculate area of trapezium QACR. Again, we have to apply the formula for finding the area of trapezium, which is what? Half into sum of parallel sides into distance between them. Here the parallel sides are QA and RC and the distance between them is AC. So, area of trapezium QACR will be half into QA plus CR into AC. Simply substitute the values. Here QA is what? What is QA? This is Y2. And what is CR? This is Y3. So, AC will be OC minus OA, which is X3 minus X2. Simply substitute these values. And here, what will you get? Area of trapezium QACR as half into Y2 plus Y3 into X3 minus X2. Now, you have to substitute the values of area of trapezium in the formula, which I have told you how to find the value of area of triangle PQRS. Area of trapezium PQAB plus area of trapezium PBCR minus area of trapezium QACR. Simply substitute these values which you have calculated earlier. You will get the area of triangle PQR as half into X1 Y2 minus Y3 plus X2 Y3 minus Y1 plus X3 Y1 minus Y2. Now this is the absolute sign, means area cannot be negative whenever you will calculate it. If you are getting the value inside this absolute sign as a negative, so after coming out the value from the absolute sign, you will get it as positive. So area cannot be negative. Before coming to this note, I'll tell you one trick how to remember this formula. Simply just see here. First you have to write down the number as 1, 2, 3. Then after 1 you have to write 2, then 3, 1. Now 1, 2 and 3. What comes here? 3, 1, 2. These values are for y coordinate and this value is for x coordinate. Means whenever you will take x as 1, means what? X 1. You have to subtract these two. You will get y2 minus y3. Then addition sign in between. When you will take x as 2, means x2, you have to subtract y3 minus y1. Addition sign in between. When you will take x as 3, you have to take the values of y coordinate as y1 minus y2. Simply put absolute sign and half before it. So this is the formula for area of triangle when you know the vertices of triangle. Now what will happen if one of the vertices of triangle becomes 0, means it is at origin, means 0, 0. So in place of x1 simply substitute 0, y1 0, means you are having a triangle whose one vertex is 0, 0. I have considered this as x1, y1. This is x2, y2. As you can take it as P, which is A, B. And the last one Q as C, D. You can take this value as x3, y3. Simply substitute the values in this formula. You will get the area as AD minus BC divided by 2. So, let us discuss some examples. Example 1. Find the area of triangle whose vertices are 2, 3, minus 1, 0 and 2, minus 4. So, we have to consider a triangle ABC. A as 2, 3, B as minus 1, 0 and C as 2, minus 4. Now, how you will calculate the area of triangle ABC? By simply applying the formula which we have just learned. This is half into x1, y2 minus y3. As I told you, 1, 2, 3, you have to take the value of x coordinate as 1. Then you have to take the values of y as y2 minus y3. Then x2, y3 minus y1 plus x3, y1 minus y2. Now, here x1 is what? 2. y1 is what? 3. You can see the A coordinates. Now, here you can see B. So, x2 will be minus 1, y2 will be 0. And from C, what will you get? x3 as 2, y3 as minus 4. Simply substitute the values. When you will solve it, you will get the area as 21 by 2. Now, since we are getting the area, so we have to remember the unit as square units. So, area of triangle ABC is 21 upon 2 square units. Now, let us discuss another example. Find the value of K for which the points 7, minus 2, 5, 1, 3, minus K are collinear. Now, what do you mean by collinear over here? For collinear points, area of triangle formed by them is always 0. Just remember this, for collinear points, area of triangle formed by them is always 0. Means you have to calculate the area by using these vertices, but you have to put that area equals to 0. So, let the points 7 minus 2, 5, 1 and 3, K are vertices of triangle ABC. You have taken this triangle which is ABC. A is 7 minus 2, B is 5, 1 and C is 3, K. Now you can calculate the area of triangle by using this formula, which is half into absolute sign x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So here x1 is 7, y1 is minus 2. Here x2 is 5 and y2 is 1. x3 is 3, y3 is k. Substitute these values. After solving, you will get 7 minus 7k plus 5k plus 10 minus 9 equals to 0. Remember, you have to put this equals to 0. So, after solving, you can find the value of k as 4. Now, exercise 7.3, question number 3. Find the area of a triangle formed by joining the midpoints of the sides of the triangle. See, midpoints of the sides of the triangle whose vertices are 0, minus 1, 2, 1 and 0, 3. Find the ratio of this triangle to the area of the given triangle. So, we have considered the midpoints as D, E and F of sides AB, BC and AC respectively. So, let the vertices of the triangle be A 0 minus 1, B 2 1 and C 0 3. So, let D, E, F be the midpoints of the sides of this triangle. So, firstly we have to calculate the coordinates of these midpoints. So, coordinate of point D. How you will calculate this midpoint? This is 0 plus 2 divided by 2. You will get 1 minus 1 plus 1 divided by 2. You will get 0. So, D will be 1, 0. How you will calculate E? 0 plus 0 divided by 2. You will get 0. Minus 1 plus 3 divided by 2. You will get 1. And for F, consider these two. 2 plus 0 divided by 2. You will get 1. 1 plus 3 divided by 2. You will get 2. So, the coordinates of point D are 1, 0, E 0, 1 and F 1, 2. Join these midpoints. You will get a triangle. You have to find out the area of this triangle and you have to find out the area of triangle ABC. Then you have to find out the ratio. Now, area of triangle is given by the formula half x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. Now, since you know the coordinates of point D, E and F, so you can easily calculate the area of triangle DEF. Since D is 1, 0, E is 0, 1 and F is 1, 2. So, x1, y1 will be 1, y1 will be 0. For x2, y2, x2 will be 0 and y2 will be 1. For x3, y3, x3 will be 1, y3 will be 2. So, area of triangle DEF, simply substitute the values, you will get as 1. And area of triangle DEF will become 1 square units. Now, you have to consider triangle ABC. You know the coordinates of point of triangle ABC as A as 0, minus 1, B as 2, 1 and C as 0, 3. Again, you can find out x1, y1. From here x1 is 0, y1 is minus 1. From here x2 is 2, y2 is 1. From here x3 is 0 and y3 is 3. Simply substitute the values in this formula. When you will solve it, you will get the area of triangle ABC as 4 square units. Now you need to calculate the ratio. So how you will calculate the required ratio as area of triangle DEF upon area of triangle ABC. You have got area of triangle DEF as 1 square unit. So simply substitute here 1, and area of triangle ABC has 4 square units. So write here 4. So the ratio will become 1:4. Now this is your home assignment. First, find the area of triangle whose vertices are -5, -1, 3, -5, 5, 2. Second, find the area of the quadrilateral whose vertices taken in order are -4, -2, -3, -5, 3, -2 and 2, 3. And the third one, verify that a median of a triangle divides it into two triangles of equal areas. You have to verify this result for triangle ABC whose vertices are A 4, -6, B 3, -2 and C 5, 2. Now let us quickly recapitulate what we have studied today. So if one of the vertices of triangle is the origin, the area of triangle can be calculated by using the below formula, which is what? Area of triangle with vertices 0, 0, P, A, B and Q, C, D is A half AD minus BC. Now second, if area of triangle with vertices P x1, y1, Q x2, y2 and R x3, y3 is 0, then half into x1, y2 minus y3 plus x2, y3 minus y1 plus x3, y1 minus y2 will become 0, and the points P x1, y1, Q x2, y2 and R x3, y3 are collinear. I hope you have understood the concept of area of triangle very well. Thank you.